In this video, we're going to be solving rational functions. Today, we're going to be using the equation y equals x squared plus 10x plus 25 over x squared plus 9x plus 20. So to start out, we're going to want to find the y-intercept. Now to find the y-intercept, you would always plug in 0 for x. So 0 squared plus 10 times 0 plus 25 over 0 squared plus 9 times 0 plus 20. This equals 25 over 20. Now this can be simplified to 5/4 by dividing both the numerator and the denominator by 5. Now when you write it next to y-intercept, you always need to have y equals in there, or else your teacher will probably take off points. So y equals 5/4. Now to find your wholes, you're going to want to factor both the numerator and the denominator. So this would be x plus 5 times x plus 5 over x plus 5 times x plus 4. Now to find the wholes, an expression has to cross out on the numerator and the denominator. So what crosses out? X plus 5. Now that you crossed out x plus 5, you set this equal to 0, subtract 5, and that is your whole. So x equals -5. Now your roots, or x-intercepts, or zeros, you would find those by using the numerator, and whatever expression is left on top, you set that equal to 0, which is already done here, and that would be your root. So x equals -5. Now, to find your vertical asymptote, you would use whatever is left in the denominator, so x plus 4, and set that equal to 0. Subtract 4 on both sides, x equals -4, and that is your vertical asymptote. Now to find your horizontal asymptote, you would need to use the expression as I learned when I was in high school: Bobo Botten eats DC. Now what does this stand for? Bobo stands for bigger on bottom 0. For example, let's say you have the expression x over x squared. Seeing that the expression x squared is more than x in the denominator, your horizontal asymptote would be y equals 0. Botten stands for bigger on top none. For example, let's say you have x squared over x. X squared is bigger than x, and it's in the numerator. So automatically, your horizontal asymptote will be none. Now for each DC, this stands for exponents are the same divide coefficients. For example, Let's say you have x squared over x squared. Both of these are equal to each other, so your horizontal asymptote would be 1, because x squared divided by x squared equals 1. Let's do another example. Let's say you have 2x squared over x squared. What would your horizontal asymptote be? 2, because 2 over 1 equals 2. So we're going to be using Eats DC in this equation because the variable x squared over x squared equals 1, because there are exponents in the first variable of the function. Remember, when you're going to be figuring out the horizontal asymptote, you always look at the first variable in the function. That will determine your horizontal asymptote. But wait, we're not done yet. You see, the holes and the x-intercept is the exact same. But that's impossible, because when you graph this equation, they cannot meet. Meaning that the x-intercept will take over and the hole will be none. Why is this, you may ask? Because the order for these functions and any rational function is that it goes in this order: vertical asymptote, x-intercept, and holes. The vertical asymptote is the strongest out of all of these categories. Then it's the x-intercept, then leading to holes. And that's how you figure out a rational function.